Hey, it's Mr. Sultana, and this video is going to be talking all about isotopes. So first of all, what is an isotope? Well, an isotope of an element has a different mass number because isotopes have different numbers of neutrons. However, all isotopes have the same atomic number. So for example, here we have lithium, like we saw before, and this lithium has 4 neutrons, and that lithium has 3 neutrons. Now remember, they have to keep the same number of protons because that's what makes it lithium, right? So they're isotopes of lithium because they have the same number of protons, but they differ only in neutrons. Isotopes will only ever differ in the number of neutrons. Now essentially what that means is that this particular lithium has 7 particles in its nucleus, right? Because we have 4 neutrons plus 3 protons. This particular lithium has 3 protons and 3 neutrons in the nucleus. So this lithium over here is actually a little bit heavier because of that. It's got a little bit more mass in there, so that's what's really important with this as well. And here's just an example. So here's one isotope of hydrogen, which only consists of 1 proton. That's all it is that makes up the hydrogen atom, is 1 proton and 1 electron. So that's actually called protium. This is deuterium, which is another isotope of hydrogen. Notice it has 1 proton as well, but it also has 1 neutron. And so that makes it deuterium, which is a different atom, but it's still hydrogen. And this is tritium, which is another isotope of hydrogen. This was actually mentioned in the Spider-Man movie. Doc Ock was actually trying to get a hold of some tritium. So that is another example of an isotope of hydrogen. All 3 of these are hydrogen. And this is what it looks like again, just a different picture of the same thing. Notice that they all have the same number of protons because they're all hydrogen. However, they differ by neutrons, and that's what makes them isotopes of each other. So remember that we have the atomic number, right, which is the number of protons. We also have the mass number, which gives you the number of protons and neutrons. What you're looking at down here is actually special notation that they use for isotopes. So they use this special notation in order to indicate exactly which isotope you're looking at. It's a little bit different than the notation we've seen in the past, and it's not the same as what's on the periodic table. And so what you have here is that the top number is going to be the mass number. So the reason why we have to include the mass number is because this is telling scientists that this is this particular isotope, right? Because the mass number will differ from isotope to isotope, because different isotopes have different numbers of neutrons. So this particular mass number is 197, and here is the atomic number of gold, which is 79. And of course you have the symbol for the element. That's the other part of this notation in order to have isotope notation. Now, keeping in mind that the number of neutrons can be found by subtracting the mass number from the atomic number subtracted from the mass number, so mass number minus atomic number. What is the number of neutrons in this gold atom, in this particular isotope of gold? So if we go and do the subtraction, go ahead and try it out and see what you get. So essentially what we do is we do 197 minus 79, and you're going to get 118. So that tells me that there are actually 118 neutrons in this particular atom of gold. Try it for platinum. So what is the number, first of all, what is the atomic number of platinum? Here's the isotope notation. What is the atomic number of platinum, according to this? What is the mass number? What is the number of protons? What is the number of electrons? And then what is the number of neutrons? So most of those are pretty straightforward, right? The atomic number is going to be 78. The mass number is going to be 195. That's the number on top. The higher number is going to be the mass number, right? The mass number is always going to be higher than the atomic number, because the mass number has protons and neutrons, and the atomic number only has protons, right? So that's another way you can tell. The higher number will always be the mass number. Number of protons is going to be 78, because that's the atomic number. Number of electrons is going to be 78, because that's the atomic number. And the neutrons, solve for the neutrons. How many neutrons would this have? So we do 195 minus 78, and that is the number of neutrons, which is 117. So this particular platinum isotope has 117 neutrons. Now we can do the same thing for this carbon, and we determine that there are 6 protons, 6 electrons, and there are actually 8 neutrons in this. So this is this. So you've actually heard of this before. This is actually carbon-14. So if you've heard of carbon-14 dating, the reason why they call it that is because this is carbon and the isotope is 14. So there's actually different isotopes of carbon, right? And this one's carbon-14 because the nucleus contains 14 protons plus neutrons. Because we have 8 neutrons plus 6 protons, so that's going to give us a total of 14. There's also carbon-13, which, how many neutrons do you think carbon-13 would have? And then there's also carbon-12, which is the most common. Now, another way to write that is actually what's included down here. This is carbon-12. When you see that notation like this, it's just the element name and the mass number. So that number following is always the mass number. So in other words, the atomic number of carbon is actually 6, right? But the mass number is what's at the end here, and that's 12, meaning that we actually must have 6 neutrons. How many neutrons must we have for this nitrogen atom? Considering that, remember, this 14 at the end is the mass number. It's not the atomic number, it's the mass number. So figure out how many neutrons are in that nitrogen atom. Okay. So then we also have, you just want to make sure that you have the correct notation, essentially. So which one of these is correct? Is it the notation on the left? Or is it the notation on the right for this particular nitrogen? And the answer is that it's the one on the left. So remember, the higher number always goes as the mass number. It's always on top. So mass number, high number, always on top. So in other words, this is nitrogen with atomic number 7 and mass number 14. So this nitrogen happens to have 7 protons and also 7 neutrons. Not all nitrogens are like that though, right? This is a particular isotope. Okay, so remember we said that essentially the number that follows the element name in this particular isotope notation is simply the number of particles in the nucleus, right? It's the mass number. So in this lithium 7, we have 7 particles in the nucleus. Protons plus neutrons makes 7. And lithium's atomic number is 3, so that means that there must be 4 neutrons in this one. This isotope is different. This would be lithium 6 on the right. But the one on the left is lithium 7. So look, based on that, what would be, so what is the mass for the following isotopes? So the mass for this particular isotope is going to be 37. And that's because we're just using the mass of the nucleus, right? That's the mass number. Another important thing that we'll get into is that the units that we use for this are very tiny units called atomic mass units, which is a short way of saying that is AMU or U. So in other words, this is actually more accurately 37U. That's the atomic mass units. That's the mass of this particular atom. What about this potassium? What would the correct answer be for the mass of that potassium? That would be 39U, right? So technically it'd be 39U. And then finally, what would the mass of this calcium be? Well, that would just be 40U. So it's very easy just to think, well, it's the number following it, but you want to remember what exactly that means. So this is actually our very last question, and the question is, how many carbon-12 atoms have the same mass as nickel-60? So think about that. Remember, carbon-12 means that that particular carbon atom has 12 particles in the nucleus. It has actually 6 protons and 6 neutrons. So how many of those would be the same mass as nickel-60? And the answer is going to be 5. So 5 of them, 5 times 12 will give you 60. So that does it for us. Thank you for watching. And remember, chemistry is everywhere.